COVID-19 virus can escape antibodies. Experts know that viruses can mutate to better adapt to their environment. But what they are still verifying is how the COVID-19 virus successfully mutated to the point of evading immune response. A team of researchers at the University of Pittsburgh School of Medicine suggested the deletions in the genetic sequence. The deletions were selectively done by the virus on its own sequence. Paul Duprex, the study's senior author, said, "Once it's gone, and if it's gone in an important part of the virus that the antibody sees, then it's gone for good." The full hunt for sequence deletions began when the preprint in November came out. Months later, scientists found these deletions in two of the concerning variants today, the South Africa and UK variants. Duprex's team first encountered antibody-resistant deletions in a sample from an immunocompromised patient who had COVID-19 for 74 days until succumbing to the infection. That period gave his team enough time to know how the cat and mouse interaction between neutralizing antibodies and SARS-CoV-2 played out. Duprex then asked help from the study's lead author, Kevin McCarthy, who previously examined how stable the virus was. Since the summer of 2020, McCarthy observed numerous deletions in the genetic sequence in the virus. The deletions occurred in the same spots of the sequence that showed a pattern. These spots allowed the virus to tolerate the change in shape without losing its potency in infecting and replicating. But the change in shape would significantly affect the potency of neutralizing antibodies, which heavily depend on exact matching. Inside the coronavirus, a molecular proofreader works around the clock to catch errors. However, the proofreader is quite blind to fix the deletions in the sequence that resulted in the change becoming permanent. Since it's permanent, the virus progeny in infected cells likely have the deletions that give them an edge to dodge antibodies. The effects of the deletions in the real world can decrease the effectiveness of COVID-19 vaccines. Right now, some vaccines have been confirmed less efficacious against the South Africa variant. During their development, the genetic material used in vaccines wasn't from the new variants. This is why vaccine-induced antibodies may have difficulty in attaching and disabling the virus. Instead of an even ratio, more antibodies will be needed to catch mutated viruses. Still, the new variants are not completely resistant to neutralizing antibodies. If that happens, scientists may use nanotech to combine nanobodies and antibodies to overcome the resistance.